In this video, we will learn about the data module within the Katosis platform. We will look at various ways in which we receive data, the formats that we require it to be in, and how that data is loaded within our platform. Once we have defined and built our data dictionary, we are able to receive data. Once we receive that data, either using the Katosis API or using a loader, that data will be ingested within our platform. Once that data is within our platform, it can then be used on our website, in our fund centers, in our product pages, within our documents or fact sheets. When receiving the data, we accept JSON, XML, CSV, and XLSX files as inputs. However, we prefer JSON because our API uses JSON format. So it's easier for us to transform the data if it is already in JSON format. When we receive the data from the customer, we need to make sure that the files are in the correct format. We want it to be automated machine readable because they are the best. It's easier to read. And if it's easier to read, it means that it's easier to implement. So if the files are easier to read, that's what we want. If the customer gives us files that are not in this format, we need to push back. And we need to get the customer to agree to give us the files in the correct format. The data that they are sending must consistently link with an identifier. And an identifier can be something such as the ISIN, which is a unique code for each fund or share class. And the reason why the data must be linked to an identifier is because we need to know where does this data belong, to which fund does this data belong to which share class does this data belong to. So if this data is linked to a specific ISIN, we know exactly which fund or which share class this data must be linked to. We prefer to receive all the data at once and not in incremental or delta. So we want to receive all the data at the same time. When we receiving the data from the customer, we need to make sure that formatting is consistent. So for example, if we're receiving percentages from the customer in different sections of their data, we need to make sure that they all conform to the same format. So for example, in our percentages, you could have a 0.114, you could have a 0.14, or you can have an 11.4%. Now, we prefer decimals over string, which means we prefer the 0.114 or the 0.14 over the 11.4%. And we will do the formatting from our side. So we will do a global formatting to make sure that these values have the percentage sign attached to it. However, we want to make sure that when we receive it, they are all in the same format. So if the customer is sending 11.4% for one data property, we need to make sure that something percent is received for the other properties as well. We need to understand the difference between zero values and null values. Zero values is the same as null values. However, in order for a machine to read it, it has to have some type of representation. A zero value is not readable. However, a null value is. So if there are sections that does not have data, we need to make sure that it's not zero that is being added to it, but we use a null value. We use the word null. We need to also make sure that all the date requirements are there. As an example, as at dates. It's very regulatory within your information that you display what data, from what date is this data representing. For example, if you're showing performance, you need to say this is the performance from this date. So it's important that when we are displaying information that you should make sure that there are all the data requirements met. We also need to make sure that there are rational and clean data labels and descriptors. We don't want stuff with special characters. It needs to be clean. It needs to represent exactly on the data that we are referencing. This is an example of a bad looking data. Now, if we look at this, it has number one, merged columns. So you can see here, this fund number is across column A as well as across column B. It has wrap text as well. So fund number is over rows 7 as well as rows 8. If we look at the sheet names, there are characters. There is a diamond, there's a star. It's not machine readable. And if we look here on top, there are unnecessary lines that is not required. And more than it's not required, it should actually be within its own section. There should be an actual property that is being used for this data. This is a clear example of non-machine readable data. This is another example. Everything is all over the place. Everything are merged columns, wrap text. It's not in a good format. It's not machine readable. If we receive data like this, we need to push back and get the customer to provide us the data in the correct format. This is an example of good data. This is a CSV file, and you can see that there are no spaces and everything has a separator. After each data, there is a separator. So this is machine readable. So it's easy to take this data and load it within our platform. This is another example of good data. As you can see on top, each column has its own property, date, fund, ISIN, fund information, fund manager, and all the data is represented within one row. So one column, one row, good machine readable data. Now that we have taken a look at the different formats in which we receive data and what the best practices are, now we will look at how we get that data within our platform. So the first thing we want to do is to always get the customer to use our API. Because if they are able to use our API to load data, the implementation is much, much quicker. If you look at the diagram, if they load the data through the API, the data is loaded immediately within the platform. If they are not able to use our APIs, we can create what we call a custom loader. And that custom loader is responsible for taking their data and transforming it to the correct format that is required by our API so that it can be ingested by our platform. So the customer would provide us with a CSV or XLSX file. We will provide them with a secure FTP server in which they can drop their files. We will then build a custom loader that will poll that location to see if there are new files. And once they see there are new files, they will take those files and they will transform it into the correct format that is required by our API so that it can be ingested within the platform. Now, if we take a look at the Kurtosis API, it is the preferred method, and it's very important that before we can load data, that our data dictionary has to be set up. If we don't have the data dictionary set up, that data will not know where it needs to go or who it belongs to. Your data dictionary are your placeholders for storing the data. Custom loaders are to be used only if the client cannot use the API. This is always specified in the contract with the customer, whether they are going to be using loaders or whether they will be using the Kurtosis API. Understanding the Kurtosis API is key to understanding how and why custom loaders are used. The API requires the data to be within a specific JSON format. If the customer cannot provide us the data in terms of how the API wants it to be in, we then need to build custom loaders. And that custom loaders are then able to take the customer's data, transform it into how the API requires the data to be in, and then it can be loaded within our platform. So once you understand the specific formats of our API endpoints, you should have a better understanding of how we require the data to look from the customer side. Anything that can be configured via the app using the UI can be configured via the API. Why do we want the customer to use the API over the loaders? No Kurtosis development required. Building a loader, if you look at the name custom loader, there's a loader built for each customer. So if we onboard a customer and they need to use a loader, we need to build one specifically for them. That takes time, which means time to implement gets extended. So if they're using the API, no custom loaders have to be built, no SFTP locations, which means quicker implementation and less overhead on our side. The standard API is across all clients and projects, which means it's easier to support and less risk. We use the same APIs for all of our clients, which means we know exactly how the data needs to look and what format it needs to be in. And the quicker ingestion of data into the platform. So if we're using the API, getting data into the platform is very, very easy. What are the challenges in using the API? If we think about our customers are usually the marketing department of an asset management company. So they do not always have the better technical understanding. So they will require more guidance if they are going to use the API. They would need more expertise or resources to implement the API connection. And troubleshooting and understanding errors might seem like a daunting task for them. So that is why we don't use the API for all of our clients, even though it's the preferred method. It's because not all our clients has the expertise or resource to be able to implement the API connection to the Kurtosis schema, or they do not have the funds to outsource a developer or a resource to build the required API connection for the Kurtosis schema. This is an example of how the API requires the information to be in. If you look at this here, you can see that the values, entity ID, type class, so this is share class data, client code, this would be the unique identifier, it will give you all of this information. And then here by the properties, it will tell you now, okay, cool. So data dictionary property called broad investor type. Another data dictionary property called distribution type, fund code, fund umbrella code. So our API requires the data to be in this specific format. And if it's not provided in this specific format, we then need to make sure that we build the necessary loaders to transform the data that the customer sends to be in this particular format.